Welcome to Homework Lib.
For this question, we have a reaction of OCl- with iodide going to OI- plus chloride. They tell us that the reaction is quick. We are also provided data showing the initial concentrations of each of the reactants and the initial rate. If we look carefully at the first two lines, we will see that the iodide concentration stays constant at 1.5 times 10 to the negative 3, and the OCl- concentration doubles from 1.5 to 3.0 times 10 to the negative 3. When the concentration of OCl- doubles, we see the rate doubling. When the concentration doubles and the rate does the same thing, namely it doubles, then this is first order. So we know the reaction is first order with respect to OCl-. But what about I-? Well, we need to see what happens when we only change the concentration of I-. When we double the concentration of I-, looking at lines 1 and 3, we see that the rate also doubles. So because a doubling of the concentration of iodide results also in a doubling of the rate, then we know it's first order with respect to iodide also. So the rate law is rate is equal to K multiplied by the concentration of OCl- raised to the first power multiplied by the concentration of I- raised to the first power. So if we were to know the concentration and the initial rate and the initial concentrations, we could solve for the rate constant. We actually have 3 sets of data that allows us to solve for the rate constant. You can choose any set of data you want, any line. I'm going to choose the first line that has the concentration of OCl- and iodide at 1.5 times 10 to the negative 3, with an initial rate of 1.36 times 10 to the negative 4. Rearrangement then gives us a K value of 60.4 1 over molarity seconds. It's second order overall because it's first order with respect to both reactants. Therefore, a second order overall reaction has units of 1 over molarity time, and the time units are seconds. So now knowing the rate constant, we can solve for the rate given any two concentrations. Given the concentrations of 2.0 times 10 to the negative 3 for OCl- and 5.0 times 10 to the negative 4 for I-, and the rate constant we just calculated, we can use the rate law to solve for the rate. 6.0 times 10 to the negative 5 molar per second.